Between the product rule, the quotient rule, and the chain rule, derivatives can get pretty complicated and messy really fast. So in this video, I will show you how to simplify ugly derivatives. In example 1, we're going to end up using the product rule and the chain rule. Let's start with the product rule by looking at this function as x squared times the square root of 1 minus x squared. Before we get started though, let's just rewrite one small detail. So I'm going to keep the x squared, but instead of writing the square root of 1 minus x squared, let's go ahead and rewrite that as 1 minus x squared to the 1/2 power. So now the product rule. The product rule says that if we want to find the derivative of a product, we will start by taking the derivative of the first function and multiply by the second function. And then we're going to add the first function times the derivative of the second function. So in the product rule, we're basically taking turns. The first time through, the first function, we will take the derivative, and the second time through, it's the second function that gets the derivative. I'm just going to use this d dx to keep track of where we are supposed to take the derivative. That's going to be helpful as this gets more and more complicated. So let's take our next pass through. So we have f prime of x equals. So we're supposed to take the derivative of the first function. We might as well go ahead and do that. That's going to be 2x. We're leaving the second function alone for now. So 1 minus x squared to the 1/2 power. There's no d dx here, so I can go ahead and just write x squared. But now we are supposed to take the derivative of 1 minus x squared to the 1/2 power. Notice that this is going to be the chain rule, so I'm going to colorize this a little bit further so you can see the outer function and then the inner function. So according to the chain rule, first we take the derivative of the outer function. So we will do the power rule and put the 1/2 in the front. So this will be times 1/2. And then we reduce this power by 1. Subtracting 1 right here would be the same thing as subtracting 2 over 2. So that's going to give us negative 1/2. So that's why we will have the negative 1/2 power. We will leave the inner function the same, but then the chain rule says we multiply by the derivative of the inner function. So I'm going to go ahead and perform that now. The derivative of 1 is 0, so we write nothing. But the derivative of negative x squared is going to be negative 2x. The power rule, the 2 comes down to the front. It is a negative 2 though, and the power becomes simply x. By now you're starting to see what I mean by an ugly derivative. We can simplify the right-hand side a little bit. I see that we have the x squared and an x. Those can be multiplied together. We have 1/2 times negative 2. That can all be multiplied together. So let's start by rewriting the first part. So we still have f prime of x equals, and we'll leave this the same for right now. 2x times 1 minus x squared to the 1/2 power. All right, but now let's clean this up a little bit. The negative 2 times 1/2 is going to be -1. So actually I'm going to change this to minus because of that. But the 2's cancel each other out. We have x times x squared will be x to the 3rd power. And then we have the factor 1 minus x squared to the -1/2 power. All right, so that's a little bit better. Before we do the next part, I'd like to teach you this little side lesson so you can really understand what I'm doing. Imagine that we have 3x to the 3rd power plus 5x squared, and we now want to factor this. This would be very easy. We're going to pull out the greatest common factor. So we look to the lowest exponent. We see that is x squared. So of course we will pull the x squared out to the front. And this is simple enough that at a glance we already know what's going to go on the inside. We're going to have our 3 and our 5, of course. But then we're going to end up with simply x right here. Now technically what we did was we divided both of these terms by the GCF of x squared. But when you divide with variables, you end up subtracting the exponents. We did 3 minus 2 and even 2 minus 2. So as a shortcut, you could think of this as doing 3 minus 2 and 2 minus 2. All right, we could have gone straight to this sort of as a shortcut. And then you see that we will have simply x, x to the 1st power from this. And this part will give us x to the 0 power. But of course, x to the 0 power is just equal to 1. So that's why there's nothing here, because it's a 1. And x to the 1 power is x. So obviously, we didn't need to go through all of this detail for a problem this simple, but baby steps. I'm showing you how a simple problem would work so that when I throw in the more complicated problem, it'll still make sense. So let's kick this up a notch and imagine that this is the 1/2 power instead of just a 2. How will that change things? So the x to the 1/2 power is still the lowest exponent. So we're still going to bring that out. Let's use the shortcut that we saw on the previous problem. We can take this 1/2 power and really just subtract that from each one of these. So we're going to wind up doing minus 1/2 and minus 1/2. So when you do 3 minus 1/2, that's the same thing as 6 over 2 minus 1/2, which is going to be 5 over 2. So we're going to wind up with x to the 5/2 power. And of course, this makes 0, which makes 1. So we write nothing. Basically, this part cancels out. And this would be the answer. Let's take one more step before we get back to our original problem. What if instead of the 1/2 power, this was a negative 1/2 power? So this is still the lowest exponent, so we're still going to take this out front. Using our shortcut again, if I take this negative 1/2 power, to figure out what goes inside the parentheses, I can just subtract negative 1/2. Now listen for that double negative though. I'm subtracting negative 1/2 from both of these. Subtracting negative 1/2. And of course, when you subtract a negative, you really wind up adding. And when you add 3 plus 1/2, that's just going to be the same thing as 6 over 2 plus 1/2, which would be 7 over 2. So we will end up with x to the 7/2 power, and these cancel out as before. As we get back to the actual problem, notice that the blue part is a common factor. See the 1 minus x squared and the 1 minus x squared. That is a common factor that we need to factor out to the front. So we look for the lowest exponent. Notice that negative 1/2 power is the lowest. So this is the one that we're going to bring out to the front. So we're going to have 1 minus x squared to the negative 1/2 power out here in the front. Now, to figure out what's going to go on the inside, let's use that shortcut where we subtract this exponent. So remember, when we go to subtract negative 1/2, we're going to wind up adding 1/2 to these exponents. So we're going to wind up adding 1/2 here and 1/2 here. So these will cancel each other out. So basically this factor is going to be gone. When you add 1/2 plus 1/2, that's a whole. So that's going to leave 1 minus x squared to the 1 power. 1/2 plus 1/2 is a whole. Obviously, we don't need to put the 1 right here. But this part over here is gone. All right, now we still have this red stuff. So if this was the only GCF, I would have a 2x right here, and I'd have my minus x to the 3rd power like this. However, there is a common factor of x. So let's also bring the x out front. So that's just going to leave 2 and x squared. So let's do that. So if we bring this x out in the front, that's going to leave a 2 minus x squared right here. I'm noticing that we can do a little simplification here on the right-hand side. So I just copy down everything else. Notice the distributive property that can happen. So we would have 2 minus 2x squared minus x squared at that point. So simplifying that just a little bit further, we have like terms. So negative 2x squared minus x squared is negative 3x squared. So we will now have 2 minus 3x squared. All right, focus on the blue part right here. Because of the negative 1/2 power, this is going to become 1 over 1 minus x squared to the 1/2 power. All right, that negative exponent just drops you down to the denominator. Also, remember that we started off with radicals. So in the end, we want those radicals back. So instead of having the 1/2 power, let's go ahead and write this once again as the square root. So we will have 1 over the square root of 1 minus x squared. So that just leaves everything that you see in red. That's as far as we can go, so this is the final answer. That is how you simplify an ugly derivative. Let's do one more example. In this one, we're going to end up using the quotient rule and the chain rule. But first, the quotient rule. Let's look at this function as a top function divided by a bottom function. Before we get started, let's rewrite the bottom function a tiny bit. So for now, we still have f of x, and our top function is x. But let's look at our bottom function as x squared plus 4 to the 1/3 power, because we know that the 1/3 power is the same thing as cube root. Now we can begin the quotient rule. For the quotient rule, we first do the derivative of the top function, and I think I'm just going to follow through with my little ddx's and set everything up first. So we will have the derivative of the top function times the bottom function. And then we're going to have minus the top function times the derivative of the bottom function. And then that will be all over the bottom function squared. So this will be all over x squared plus 4. Well, the 1/3 power, if you take the 1/3 power and you square, you're going to wind up multiplying these, and that'll be the 2/3 power. Okay, so we have now squared this denominator. Our next step is to perform the derivatives that we have indicated here and here. The denominator has no derivative, so we can go ahead and just copy that down, x squared plus 4 to the 2/3 power. We have our first derivative right here, but the derivative of x is just 1. So we really don't even need to write that down. I'll be erasing that in a second. And we can just bring down the x squared plus 4 to the 1/3 power. And then we have minus x, which we just bring down. Now it's time for the derivative of this blue stuff over here, but be careful. I warned you that we would have to do the chain rule. In fact, I'm going to colorize this a little bit further so you can follow what I'm doing. So we will look at this as an outer function in blue and then the inner function in yellow. According to the chain rule, we need to do the derivative of the outer function first. The 1/3 is the outer function. So by the power rule, the 1/3 will end up in the front here. So this will be times 1/3. All right. We need to reduce this by 1. So in this case, that means subtracting 3/3. So that's going to make negative 2/3. And the inner function remains unchanged. So we still have x squared plus 4. However, for the chain rule, you then multiply by the derivative of the inner function. So the derivative of x squared is 2x. The derivative of 4 is 0, so we write nothing further. So this is what we have right now. I'm noticing that we can do a tiny bit of simplifying over here on the right-hand side. I'm going to end up putting the 2 in front here, and then we'll have the x times x will be x squared. Actually, so we have the 1/3 times 2, which will be 2/3. So you can see that I've made this simplification that I suggested. Again, 1/3 times 2 is where the 2/3 is coming from. And then the x times x became x squared. So let's go ahead and scroll down and factor. So notice that we have a common factor of x squared plus 4 in both of these terms. So I'm going to leave the denominator alone for now. So in the denominator, we will still have this x squared plus 4 to the 2/3 power. We will deal with that later. But let's pull the common factor out in the front of the numerator. So I'm going to have x squared plus 4 in the very front. The power needs to be the lowest exponent. Negative 2/3 is the lower of these two exponents, so I'm going to pull out the negative 2/3. To imagine what gets left behind, I'm going to use the shortcut that we developed on example 1. We are going to subtract negative 2/3 from each one of these exponents. Remember, when you subtract negative 2/3, you're really going to end up adding 2/3. So, as a shortcut, I can add 2/3 to this exponent, and I'm going to add 2/3 to this exponent. Of course, right here, these cancel out completely, so this factor is gone. So that's why I will only have negative 2/3 x squared on this side of the parentheses. But out to the left, I'm adding 1/3 and 2/3. That's going to make 3/3, which is just 1. So that's why I'm going to have x squared plus 4 to the 1 power, which I really don't need to write down. In fact, because there's no exponent, I don't even need the parentheses. So let me just take that out for a second. So, focusing on these parentheses a little bit longer, the x squared and the negative 2/3 x squared are like terms. Essentially, we have a 1 x squared and then minus 2/3. So the question is, what is 1 minus 2/3? Well, intuitively, hopefully, you know that this is going to be 1/3. 1 whole minus 2/3 is going to be 1/3. But you could look at this as 3/3 minus 2/3. Okay, so that's why we're going to get 1/3 x squared when we combine those. So we've gone and done it. Combining like terms, x squared minus 2/3 x squared gave us 1/3 x squared, and then we just brought down the plus 4. Now we need to go ahead and divide these common factors. Notice they both have x squared plus 4. Only the exponents are different. This will happen a lot because of the way the chain rule works. Remember that if you have n to the a power divided by n to the b power, that's just going to be n to the a minus b power. So as we divide these two factors, we're going to have x squared plus 4 for sure, but for the exponent, we need to subtract negative 2/3 minus 2/3. And of course, negative 2/3 minus 2/3 is negative 4/3. So that's why we're going to have the negative 4/3 power. And we still have the 1/3 x squared plus 4 on the right-hand side. So because we have this negative exponent, this blue part is going to drop down to the denominator. So we're going to end up with something that looks like this. All right, we're going to have our x squared plus 4 to the 4/3 power in the denominator, while we have 1/3 x squared plus 4 in the numerator. So there's just one more thing we need to do. Let's take this 1/3 and put it outside of the parentheses as a common factor. How do we do that? Obviously, we're going to have x squared sitting here because we've taken away the 1/3. But what about the 4? Just ask yourself 1/3 times what would give you 4? And the answer is 12. Imagine you were to do the distributive property. 1/3 times x squared would give you the 1/3 x squared back, and then 1/3 times 12 would give you the 4 back. For our final answer, we don't like having a fraction inside of a fraction, so let's deal with that. We can take this 1/3 and move it to the front. I'm sure you'll see that multiplying by 1/3 in the front and multiplying by 1/3 in the numerator are the exact same thing. For example, if I have a over b, and I'll just write it twice, it doesn't matter if I'm multiplying by the 3 in the front or if I put 3 in the numerator, both of these would be the same. So I'm choosing to put it in the front like this. But in this form, it's easy to see that I'm multiplying 1 by the numerator and 3 by the denominator. If I multiply 1 times the numerator, that changes nothing. If I multiply 3 times the denominator, I'm really just putting the 3 in the denominator. So this will be the final answer.